50 years. That's how long the world's best scientists, the ones with the PhDs, the billion-dollar labs, the Nobel Prizes, spent trying to crack 5 problems that could change human civilization forever. They couldn't do it. Then AI showed up, and in just the last few years, it solved them, not helped solve them, not made progress on them. Solved them. A problem that stumped biochemists for half a century, cracked in days. A new antibiotic, something humanity desperately needs, discovered in hours, not decades. 2 million new materials that could power the future, predicted overnight. A weather model that now beats the world's most powerful supercomputers. And a breakthrough in nuclear fusion that scientists called impossible to control, tamed by a machine learning on the fly. This is not science fiction. Every single one of these breakthroughs is real, published in peer-reviewed journals, and already changing the world right now. Welcome to factlabpro. I'm about to show you 5 discoveries AI just made that scientists couldn't crack in 50 years. And what they mean for your future? Let's go. AI solved a 50-year biological mystery in days. Discovery number 1, and if you only remember one thing from this video, make it this. Inside your body right now, there are roughly 100,000 different types of proteins. Every single one of them does a specific job. Digesting your food, fighting infections, carrying oxygen through your bloodstream, building muscle, firing neurons. Your entire biology runs on proteins. But here's the thing scientists discovered decades ago. A protein's job is determined entirely by its shape. The 3D shape it folds itself into. Change the shape, and you change what the protein does. Or break it completely. That's how many diseases work. Misfolded proteins. So scientists figured if we can predict the shape a protein will fold into from its chemical sequence, we can design drugs to fix broken ones. We can develop cures for diseases we've never been able to touch. There was just one problem. Figuring out a protein's 3D shape experimentally took years, sometimes a decade, with $100,000 in equipment per protein, and there are 200 million known proteins. You can do the math. Scientists called this the protein folding problem, and they'd been failing to crack it computationally for over 50 years. Then, in 2020, Google DeepMind's AI system, called AlphaFold, entered the annual protein folding competition, the CASP14 Challenge. It didn't just win, it destroyed the competition with near experimental accuracy, doing in minutes what had taken years. But the real game changer came next. In 2022, DeepMind released AlphaFold's predictions for over 200 million protein structures, essentially every protein science has ever identified, and made the entire database free for any researcher on Earth to use. The numbers are staggering. Over 3 million researchers in more than 190 countries have now used AlphaFold. Research linked to it is twice as likely to be cited in clinical medicine papers. It's already being used to hunt for new cancer drugs, design better vaccines, and develop treatments for diseases that have defeated medicine for generations. In 2024, this work earned the Nobel Prize in Chemistry. Let me put this in perspective. What AlphaFold accomplished would have taken hundreds of millions of years to achieve experimentally. AI did it in months, and in May 2024, DeepMind released AlphaFold 3, an even more powerful version that can predict how proteins interact with DNA, RNA, and drug molecules. That's the next frontier of drug design, and AI is already there. AI found a new antibiotic in hours. Scientists searched for decades. Discovery number 2. And this one might be the most urgent. Right now, the world is losing a war it doesn't talk about enough. Bacteria are evolving. They're becoming resistant to the antibiotics we've relied on for decades. Tuberculosis, MRSA, E. coli strains. More and more of them are developing resistance to every weapon medicine throws at them. The World Health Organization has warned that drug-resistant infections kill at least 700,000 people a year today. Without new antibiotics, that number could climb to 10 million deaths per year by 2050. That would make antibiotic resistance one of the deadliest forces on Earth. The problem? We haven't found a genuinely new class of antibiotics in decades. Why? Because hunting for new antibiotics the traditional way means physically testing millions of chemical compounds one by one. It's slow, it's expensive, and the pharmaceutical industry has largely abandoned the search because it's not profitable enough. Then MIT researchers decided to let AI do the searching. In 2020, a team led by Professor James Collins used a deep learning model trained on the molecular features of about 2,500 known compounds. They then set it loose on a library of over 100 million chemical compounds, screening each one in a matter of days for antibiotic potential. The AI found something extraordinary, a molecule that had previously been tested as a diabetes drug, completely ignored for antibiotics, turned out to have powerful bacteria-killing properties unlike anything in existing medicine. They named it halicin, after Hal, the AI from the film 2001, A Space Odyssey. And halicin doesn't just work. It works on some of the nastiest drug-resistant bacteria on the WHO's most wanted list. It killed Clostridium difficile, Acinetobacter baumannii, and Mycobacterium tuberculosis in lab tests. It also did something extraordinary. In a 1-month experiment, E. coli bacteria failed to develop resistance to halicin, in complete contrast to existing antibiotics like ciprofloxacin, where resistance emerged rapidly. And that was just the beginning. In late 2023, the same MIT team used an improved AI model to discover an entirely new class of antibiotic compounds. Compounds that could kill MRSA in both lab dishes and mouse models with very low toxicity to human cells. What would have taken pharmaceutical companies decades and billions of dollars, AI did in days. Halicin has not yet completed clinical trials in humans, so it isn't in your medicine cabinet yet, but the discovery of its antibiotic properties by AI is a landmark moment in the history of medicine. AI discovered 800 years worth of new materials overnight, discovery number 3, and this one reshapes the future of technology itself. Think about how much of modern civilization depends on materials we discovered by accident or through decades of painstaking lab work. Silicon for computer chips, lithium compounds for batteries, graphene, that single atom thick carbon sheet that's stronger than steel. Each of these took years, sometimes decades, to identify. And scientists have always known there are millions of undiscovered materials out there, compounds with properties that could revolutionize solar cells, build better batteries for electric vehicles, enable superconductors that transmit electricity with zero energy loss. The problem is, traditional materials research is a guessing game. You tweak known compounds. You mix elements, you test, you fail, you try again. Decades of that work had identified around 48,000 stable crystal structures that humanity could actually use. In November 2023, Google DeepMind flipped that number upside down. They released an AI system called GNoME, Graph Networks for Materials Exploration. And GNoME didn't discover a few new materials. It didn't discover a few hundred. It predicted the stable structures of 2.2 million new crystals. increasing the total number of known stable materials by a factor of 10. To put that in context, DeepMind described the achievement as the equivalent of nearly 800 years worth of traditional materials research, done overnight. And these aren't just random chemical guesses. The AI identified 380,000 of these materials as particularly stable, the best candidates for actual laboratory synthesis. Among them, 52,000 new layered compounds similar to graphene, any of which could unlock new superconductors. Previously, science had identified only about 1,000 such materials. GNoME found 52 times more. It also identified 528 potential new lithium-ion conductors for better batteries, 25 times more than all previous studies combined. Researchers at Lawrence Berkeley National Laboratory have already begun independently synthesizing some of these AI-predicted materials in their robotic lab, and they're confirming the predictions are real. Think about what this means. The battery in your phone, the solar panel on your roof, the chips in your computer, all of them could be radically improved by materials that AI has now put on a map for scientists to find. AI outperforms supercomputers at predicting the weather. Discovery number 4, and this one affects everyone on Earth, literally. Weather forecasting is one of the hardest computational problems in existence. The atmosphere is a chaotic system, billions of variables interacting simultaneously. To predict it, meteorologists use numerical weather prediction, physics equations solved on some of the world's most powerful supercomputers. The European Centre for Medium-Range Weather Forecasts, ECMWF, runs one of the most advanced of these systems. Their flagship model, called HRES, runs on infrastructure that costs hundreds of millions of dollars to operate. In December 2023, Google DeepMind published the results of a test that stunned meteorologists. Their AI system, called GraphCast, went head-to-head with HRES across 1,380 separate verification targets: temperature, humidity, wind speed, storm tracks, and more, across a full year of global weather data. GraphCast outperformed the ECMWF model on 90% of those targets. But here's what makes this truly jaw-dropping. HRES requires a supercomputer and hours of computation time. GraphCast generates a full 10-day global weather forecast in under 1 minute on a single computer chip. Real-world tests have already proven the difference. During Hurricane Lee in 2023, GraphCast predicted the storm's Nova Scotia landfall 9 days in advance. The ECMWF's traditional model only called it 6 days out. 3 extra days of warning for a hurricane landfall could mean hundreds of thousands of evacuations, could mean lives saved. There's a deeper impact here too. Until now, cutting-edge weather forecasting required computing infrastructure only wealthy nations could afford. GraphCast can run on a single cloud server, costing a few dollars per hour. The World Meteorological Organization has specifically highlighted this as a major equity breakthrough, meaning developing countries can now access global forecast quality that was previously available only to the United States, Europe, and Japan. The European Centre itself was so impressed, they moved their own AI forecasting model to full operational status in 2024. AI isn't assisting weather forecasters, it's replacing the supercomputers. AI cracked the hardest control problem in physics. Discovery number 5, and this one might be the most consequential of all. For the entire future of energy on this planet, nuclear fusion is the holy grail of clean energy. It's the same process that powers the sun, smashing hydrogen atoms together to release enormous amounts of energy, with no carbon emissions, no long-lived radioactive waste, and a fuel source, hydrogen, that is essentially unlimited. If we could harness it, fusion would give humanity clean, cheap, virtually limitless power forever. Scientists have been working on this for 70 years, and they've made incredible progress. The basic design, a device called a tokamak, a giant donut-shaped magnetic chamber that contains superheated plasma at temperatures hotter than the core of the sun. Works in principle. We've achieved fusion. The problem is controlling it. The plasma inside a fusion reactor is unstable by nature. It's a superheated gas of charged particles spinning at 180 million degrees Fahrenheit, means around 100 million degrees Celsius, held in place only by powerful magnetic fields, and without warning, it can develop instabilities, what physicists call tearing instabilities, that cause a disruption, a sudden catastrophic collapse of the plasma. When that happens, all that energy slams into the reactor walls in milliseconds. It doesn't cause a nuclear explosion, but it could destroy the inner lining of a $20 billion machine. Traditional control systems could detect these instabilities after they formed, but detection is not prevention. By the time you see it coming, it's already too late. Physics-based systems simply can't compute fast enough to predict and avoid the disruption before it happens. In February 2024, Princeton University researchers published a landmark paper in Nature. They had trained an AI using deep reinforcement learning, the same technique that taught AI to master chess and video games, on the plasma behavior inside D3D, the largest magnetic fusion facility in the United States, located in San Diego. The AI learned to monitor the plasma in real time and, for the first time in history, actively adjust the magnetic fields to prevent tearing instabilities before they formed, not react to them, prevent them. This had been considered essentially impossible with traditional control systems. The AI did it. Developing solutions like this increases confidence that we can run these machines without any issues, said Princeton professor Egeman Coleman, the study's senior author. This is not a small step. Every single commercial fusion reactor we ever build will need this kind of AI control. Without it, fusion power plants simply can't operate reliably. With it, we may finally be on a realistic path to the most important energy breakthrough in human history. The sun has been fusing hydrogen for 4.6 billion years. We're just learning to do it, and AI is teaching us how. 5 discoveries. 5 problems that defeated the best scientific minds on Earth for decades, solved, in some cases in days, by artificial intelligence. Protein folding, a 50-year mystery, cracked, putting 200 million protein blueprints into the hands of every researcher on the planet. A new antibiotic found in hours, one that bacteria can't easily defeat, at a time when resistance is becoming a global emergency. 2 million new materials mapped. 800 years of human knowledge generated in a single run. Weather forecasting that now beats the world's most powerful supercomputers. And the hardest control problem in nuclear physics, tamed by a machine that learned to feel plasma the way a human hand feels heat. We're living through the fastest acceleration of scientific discovery in human history, and we're just getting started. If this blew your mind, hit that like button. Subscribe if you want more science that actually matters. Drop in the comments, which of these 5 discoveries do you think will change your life first? I'll see you in the next one.